All right, I think numbers are roughly stable, so I think we can probably start now, and I think some people will still join, but I think they can join as we go live. So welcome everyone to our open day of the Intelligent Earth Center for Doctoral Training in AI for the Environment. It's a real pleasure to have so many people interested in joining. And it's a real pleasure to actually get started with this program. We've been working on this for quite some time. We've now putting it together in a very, very rushed pace because we have only limited time to set it up until the admissions open, which are open now, until the deadline closes in January, and then also to get everything set up and running for the intake in September. But we're really excited to do that. I'm just mentioning this because we are a startup. And so we may not even have all questions, answers to all questions you have later, because we're working on this as we set up the program. So please be patient with us, but we're super excited to get started on this. So before we kick off, I should introduce us. So my name is Philipp Stier. I'm the director of the CDT, and I'm an atmospheric physicist with strong interests in climate, and work a lot across the interface of climate and AI. And I should ask my colleagues to introduce themselves. So Hannah, do you want to go next?
Yes, hi, good morning, everybody. My name is Hannah Christensen. I also sit in the physics department. I have a big interest in how we make weather and climate predictions in particular, interest in quantifying uncertainty and how we can use AI to help us here.
Great, thank you, Hannah. Laura?
Hi, everyone. My name is Laura Stevens. I'm an associate professor sitting in the Earth Sciences department, and I'm a glaciologist, which is somebody who studies ice. And mostly I study ice on Earth, Earth's large continental ice sheets, from field-based and numerical modeling approaches. And I'm really excited to be involved in this CDT because there's a huge amount of data coming in on ice at volumes that we cannot handle just alone without AI approaches. So looking forward to today, and happy to answer any questions about Earth sciences.
Brilliant, thank you. Andrew.
Hi, everyone. I'm Andrew Markham. I'm a professor of computer science, but my background is actually in electrical engineering. I've been doing a lot of basically interdisciplinary work where we use AI or machine learning tools to make sense of noisy sensor data, which is coming from all sorts of sources to try and make better sense of the world.
Brilliant, thank you. Sophie.
Good morning, everybody. My name is Sophie Nixie. I'm interim program manager, and I've had previous experience of running a CDT in synthetic biology, and now I'm working with the team for Intelligent Earth. Thank you.
Brilliant, thank you, Sophie. And Sophie is almost the most important person, because if you write emails to the contact address given on our webpage, they typically will be answered by Sophie. So it's nice to connect this with a face. So I will start off by giving a very brief overview of our vision for this Center for Doctoral Training, and before we then move on into the program. So to motivate the drive why we set this up, I won't surprise you with the fact that Earth is facing quite existential environmental challenges. And this includes climate change, as you will be acutely aware. So this is just an illustration of a heat wave in the northwestern Americas that was really unprecedented in its extent, and in particular also the temperature anomaly. And then obviously this is strongly linked to wildfires and many other bits that we are now experiencing globally. And if you can think of biodiversity loss, and this is just a map of biodiversity intactness. So just to give you a sense, there's many areas where this is fairly bright, and that means biodiversity intactness, whatever way you would define it, is not so high. Then you can think of obviously air pollution. Air pollution kills about 7 million people every year. So it is a very, very important topic that needs urgent solutions. But you can also think of natural hazards in a broader sense. That includes flooding here, and there's links to climate change, obviously, but it includes also earthquakes and volcanoes and other natural hazards. And again, we often don't have early warning systems in place which exploit all the data that's available. At the same time, we also are acutely aware from news and many other media that AI and machine learning are really transforming already sciences. And examples you may have heard about, I want to explain them in detail. For example, AlphaFold, so the prediction of protein structures with machine learning. And it's really important already for detection of exoplanets and other features, but also it's really taking over, not taking over, but playing a very, very active role in weather prediction. And all of these things, you see, they happened in the very recent years. So it's a really dynamic time how AI and machine learning are beginning to transform sciences. Now, thinking about environmental science in a broader sense, we're also in a fantastic time to do research in this space. We have a fantastic new data. So this is just a movie from a sort of a next generation climate model where you simulate clouds, but also biogeochemical cycles, so aerosol cycles here globally at a really unprecedented resolution. And this is an extremely big data that you have to analyze and comprehend, but also these models are extremely expensive, and AI will certainly play a role in the future of such models. And thinking of observations, we're also in an extremely data-rich area of observations. So these are pictures from one of our partner organizations, Planet. They run fleets of CubeSats, so small satellites, not bigger than a shoebox or so. And they provide ultra-high resolution satellite imagery globally with a very high time resolution, which you can do because you have so many of these small satellites out. And again, it's a flood of data that provides a huge amount of constraint on our environment that we currently don't fully exploit because we don't have the tools and the ability to digest it all. So it's a really good and exciting time to do science in this space. So that drives a bit the motivation for us. Why Intelligent Earth? So we know there's many environmental crises. There's key science questions that remain unresolved, and they're really important to tackle some of these crises, but also to understand them. It's just fundamental science as well. We have vast and really complex multimodal data from very different types of observations, models, and sensors, and we need to find ways to understand and analyze these data sets. And at Oxford, we're really excited because we have very broad and deep domain expertise in all these areas, and we have a fantastic set of partners in the CTT. So this all comes together. So what we want to do is to really train a new generation of PhD students that are equipped to tackle some of the most pressing environmental issues using AI. And you see the little dots at the end of this here. It's using AI, but it's also while advancing AI itself. So we don't see this as a graduate school where you just take off-the-shelf ready AI tools. We want to, with complex environmental science questions, contribute to the advancement of AI itself. And so it's a real development cycle. Another set of dots at the end. We want to do this in a really positive and inclusive environment. So while we strive to do excellent, outstanding science, this should be fun and positive, and it should be very inclusive. So the vision for the program is to have this interdisciplinary training program, and I'll tell you in a bit what I mean by interdisciplinary. And we think of broadly two entry streams, but you can think of it's probably a gradual scale of many, many people in between these streams. So we broadly think of people joining us from numerous environmental science backgrounds, and broadly from data science backgrounds, maths, maybe statistics, computer science, physics, that maybe haven't had a lot of exposure to environmental sciences. And we train and cater for all of these. And we tackle all these questions in 5 closely connected themes. So we look after climate, biodiversity, natural hazards, environmental solutions, and importantly, a theme also on core AI research or machine learning research, which can be really more fundamental, but is keeping environmental science and data in mind. So it's not entirely detached, but it doesn't directly need to solve a climate science or biodiversity science question, but it's really more fundamental AI research. So who are we? We are some departments in Oxford University. So we're physics, biology, computer science, earth science, engineering science, statistics, and the School of Geography and the Environment. And we have a really fantastic set of partners on board. So we have a lot of non-academic partners, and I'll explain their role in just a minute. You see them. I won't now go through the full list. Actually, I will go through the list. So it's IBM, Google, DeepMind, NVIDIA, ESA, Planet, the Met Office, the Frontier Development Lab, then AIM South Africa, so the African Institute for Mathematical Sciences, the UK Centre for Ecology and Hydrology, the National Centre for Atmospheric Science, On the Edge, and National State and Conservation X-Labs, and the Satellite Applications Category. So that's what you find on our webpage. Actually, ever since we just started our program, this list is growing and it will continue to grow. So we now can also mention AIOI, the R&D Lab, as one of our new partners, and the European Centre for Medium Range Weather Forecasting, and the Computational Science Division of the Science and Technologies Facilities Council. So this, again, this list is growing. Why does it matter? Because it provides fantastic opportunities for you actually to interact with these partners. So the way, when I said before, it's an interdisciplinary program, it is, in this case, it's really intrinsically interdisciplinary, because every PhD project will be supervised by an academic from an broadly environmental science background and an academic from an AI machine learning background from all our departments. And they additionally have a non-academic advisor from one of our partners. And this non-academic advisor also serves as a host for non-academic secondment. So students have a real interaction with the real world outside of academia. And this is obviously also one of the many possible career paths that people may take afterwards. We match students and supervisors in the first 2 terms of the training program. So you don't need to identify necessarily a supervisor before at all. You really will have an opportunity to meet them, and this matching will happen at the start of the program. Which degree do you actually get? So you will have a primary supervisor, and this means once you sort of leave the early training program and move to the department, you move to the department of your primary supervisor. And so it depends on the focus of the project and the main supervisor and the background of the student. And you will also then get a degree from the department you're transferring into, which could be computer science, or it could be physics, or it could be geography. So it really depends on where your main supervisor sits. So you may have wondered why are there no project descriptions on our web pages? Because it's a student-led program. So what do we mean by that? We mean that we don't advertise a fixed set of projects. We instead actually admit people to the program, and students will then have opportunities to develop their own projects with their supervisors based on their research interest. And it's a real sort of a development cycle of their projects. It's the first sort of big proposal you write in your academic or scientific career. There's a small exception. There will be some partner-led projects which are really driven by partners, and they're open for students to apply. And they will be a small number of projects which are also specifically advertised. So we plan for an annual intake of around 20 PhD students, but the number is not exactly fixed, but that's roughly what we have in mind. And it's important to mention that the studentships are fully funded. So they include the stipend, the fees, and the research and travel allowance. So it's not foreseen that you have to bring in your own money. It should be fully covered by the program, which is really important for access and diversity as well. So I won't say too much about the training program, because my colleague Laura will pick that up in a little bit. I'll just say a few things. So there will be training, which we'll discuss in a bit. But on top of this, we see actually the CDT as the core of a big community in Oxford. So you will be part of a community where we get together also for cross-cohort hackathons with everyone together and our partners and many academics. We have an annual conference where everyone gets together. And we will also have weekly seminars. So it's really, we see this as a fun and exciting opportunity for all of us to learn together while training you as PhD students. And the training will be also individually tailored for each PhD student. You may have seen we have these different entry streams. Everyone brings a slightly different background. There's no point to teach people exactly what they've already heard before in lectures. So there will be a tailoring of the training for each student as they admitted, and this will be happening. This tailoring will be happening in the beginning of the project or of the training. What are we looking for in applicants is an important question. So first of all, we strive for inclusivity and diversity, and we really want to recruit candidates from a wide range of backgrounds. So if you think Oxford has an interesting name to it or so, don't be intimidated. We want to look for candidates from all backgrounds, all universities, from the UK, but also worldwide. So it's really an inclusive program. We seek for applicants that have a really strong interest and the motivation in the development and applications of AI for environmental science and solutions. And it's important that this includes also the word development. So we really want to dig deeper, not just the application. And because of this, we think that candidates need some strong quantitative skills, because it's important that you really understand what you're doing, and we train you in these. And there are some requirements just in prerequisites, because you need to understand the underlying methods and fundamentals. So I already mentioned these entry streams and that they reflect some of this already, and that we look for people basically have some quantitative background. And importantly, we want them to really have a broad interest in some or all of the 5 intelligent Earth themes. So you really need to be excited and driven by what we offer. With that, I'll actually stop here and would like to thank you for your attention. On behalf of the whole team, I didn't introduce everyone before, and I'll pick up the people who I haven't introduced before here now, because we have images with them. So also, unfortunately, can't be here today is my colleague Steve Robert from Engineering Science, who's an expert rooted in a long background in astrophysics, but now an expert in machine learning in a wide range of applications, from finance to the environment and many other bits. Then Adrian Thomas from the Department of Biology, who has a strong background in biomechanics, has been working in the startup scene and so on, has a wide perspective of the world. And then there's Louise Slater, who is a professor of hydroclimatology. She's an expert on floods and flood modeling and using machine learning for many of these. And she's also on the management committee. And I see also my colleague VYT joined. So I ask VY to introduce himself briefly.
Hi, I'm Yi. Thanks, Philip. So I'm a professor of statistical machine learning based in the Department of Stats here. My background is actually pretty interdisciplinary on the fundamentals side. I've been in a computational neuroscience department. My PhD was in computer science. I work across lots of different areas in machine learning. I'm also a research director at DeepMind.
Brilliant. Thank you very much, VY. So all of this was meant to give you a sort of a first teaser and idea of what we strive to do. You probably have lots of questions, and we will pick up all the questions in a Q&A session afterwards. But I think what we want to do next is to motivate a little bit just to give you some teasers of some of the questions we might actually be interested in. It's definitely not comprehensive, covering all areas, so it's a very big field. But I want to ask my colleague Andrew now to take over from here. If I stop sharing, there we go.
Great. Okay. Thank you very much, Philip, for that overview. So I'm just going to give you an outline of kind of AI, very much from my side in computer science, but I know that my colleagues in statistics and engineering have a huge other range of topics and areas as well. So let's first go through, like, why? Why AI? What's this ML? What do we need this for? Well, AI and machine learning, they seem somewhat magical at the moment. We can do everything with them. We can predict the weather, fold proteins, play games, control robots, and of course, make cute pictures. That's what AI is all about. But fundamentally, I think it's always important to take it back to the beginning. What is AI and ML? Well, it's just fancy curve fitting with lots of data. So if we just always remember that all we're trying to do is we're trying to take some data and model a curve or a line, it's nothing more than nonlinear regression. Okay, and it's just got some sophistication on top. So when and why do we use AI and ML, and what can we use it for? Well, we often use AI or ML when we just have too much data. So we need to ask the computer to basically churn through all the data to then make sense of it so that a human doesn't have to sit and manually label or annotate all the data. So this is a project that we did a few years ago where we put some small sensor devices onto lions to basically figure out what are they doing and when are they doing it. So this is a full stack machine learning in that we actually have machine learning working on these very tiny devices, obviously not very sophisticated machine learning because we don't have a GPU on these little microcontrollers, but we make these devices, and then we have our lion sitting out there with its blinging collar that runs for, a few weeks, or in one of these cases, we ran this data continuously for 2 years. So basically we're getting thousands, tens of thousands, hundreds of thousands of hours of data. And then from this, we get all these streams of sensor data. And here what we have is we have a mixture of accelerometry. And for the first time, we also put microphones onto the lions themselves, so we could hear exactly what they were doing. And this gave us a really rich data set, but also a massive data set. There's no way that you could get a person to basically sit and go through all the data to figure out what the lion was doing when. So here comes machine learning to the rescue. We basically take all our data, we build a small model, and we ask it to classify these various behaviors, such as when the lion is stationary or running quickly, or whether it's slowly walking. And we can also pick up some new behaviors that were not possible before. And these are things like eating and drinking, which are really important for understanding how a lion uses its landscape and what decisions does it make. Is it going to try and run after some prey, or is it really thirsty and actually just needs to go down to the water hole? So from this, we get really detailed behavior profiles where we can say for every second of the day for a whole year, what exactly a lion was doing. Was it running or sleeping or walking? And then we can start to answer questions about how a group of lions behave. And then look at questions about how does this behavior change over time, perhaps with increasing global temperatures, for example. How do their behaviors alter? So this data gives us the insight that we need to answer these questions. We can also do things like learn their raw prints. So it turns out that lions have unique voices, which is not surprising if you have cats, because they definitely sound different. But we can use this to then work out who said what and where, for example. So from this, we can start to build a much richer picture of how lions are using their landscapes to communicate and interact with one another. We can also use machine learning when existing tools are too slow. So here's another example of a project that we did in our lab. And this is to model seismic wave fields. Now, the traditional way of doing this is you use finite element or finite difference simulations and put all this data into these giant models that sit there and break up the world into little pieces and then communicate between all the pieces precisely. It works fantastically well, it's highly accurate, but you do need your supercomputer to sit there for a few days to work out your solutions, especially if you're doing 3D inversion. We can approximate this using machine learning, so basically neural networks, and we teach them a little bit about physics to say, look, this is a constrained problem. Here, we'll give you some equations of the wave field, and if you can go and use this to constrain your answer. And under the hood, there's all sorts of interesting tools and techniques coming from computer science on basically scheduling and breaking down divide and conquer problems to then get our scalability so that we can end up with systems that could be an order of magnitude or even 2 orders of magnitude faster. But the trade-off is we typically not as accurate as the exact solution. So these are the trade-offs that we need to take into account when we're using our AI and machine learning. We can also use machine learning when our problems are actually a bit hard. They're too hard for people, and it's often because it's a mixture of too much data, but it can also be that the signal we're looking for is quite small. So this is an example where we're trying to use satellites and the signals from these hyperspectral satellites to track and monitor methane pollution emissions around the world, which obviously, you know, we have COP28 at the moment. So there's certainly attention on the fact that there is a lot of methane emission, which is a significant global warming gas. There are new satellites that are being put out, which are basically have many, many spectral bands. So basically, it's like a super camera that's got 200 channels. This is too much data for us to work with. And what we see is that the existing techniques, such as this MAGIC over here, they compress the bands down into a very small picture using a matched filter, which we can then treat as an image. But it's not nearly as accurate, and we miss out small plumes. So big plumes are easy to get, but small plumes are missed by these existing techniques. By looking at all of this hyperspectral data at once and letting the machine learning model work out which bands are actually the most important, we can then detect smaller plumes better, which means that we can get a better idea of what's happening over the whole world all the time in terms of methane emission. We don't have to do on-the-ground surveys. And then, of course, we can run it on board the satellite itself. So this is some very recent work where I believe we were one of the first groups that has publicly run machine learning on an actual satellite in outer space. So in summary, machine learning and AI are fabulous tools to enable environmental innovations. But like all tools, the craft is knowing which tool to use when. Do you use the delicate precision hammer, or do you hit it with the giant sledgehammer? And that's part of what we're doing through this interdisciplinary network of the CDT, is to basically teach you like which machine learning tools are applicable at certain points in time. Great, thank you. I'll hand back over to Philip now.
Fantastic, Andrew. It's so fascinating. I could ask now 10 or 20 science questions, but we won't have the time for this, and this is not the area we want to touch on today. So what I'd like to do now is to just very briefly go around the room and quickly see from the people on the management committee, just to say a couple of sentences why they find this exciting. Why would they want to be interested themselves in a program like this? And I'll kick off with WeWhy, because I know WeWhy has to move on.
Thanks, Philip, and thanks a lot, Andrew. It's a great presentation on use of AI and machine learning. So for myself, I do a lot of fundamental research in machine learning and AI, but I find a lot of the applications here in the environmental sciences to be very exciting. There's a lot of very, large-scale data and structured and unstructured data, and it's trying to answer important questions that that can kind of help humanity and the Earth as well, of course. And I think that there's a lot of interesting basic research that can be done in these areas. For example, I was recently very excited about the use of machine learning in modeling PDEs and ODEs and data assimilation, where, so one of the things that's kind of interesting in this area is that we don't have full observations of all the processes that we know about. We have partial observations, and the question is, how do we assimilate that data into our knowledge of what's going on in the environment? And I think that that's quite an interesting area for machine learning scientists to work on as well.
Brilliant. Thank you very much, WeWhy. I don't know who wants to go next. Maybe Anna.
Great, thanks, Philip. Yeah, I'm really excited because it's a very timely program. It feels like the time is completely right to be bringing together AI and environmental science. We've seen so many big developments in AI recently, for example, to do with generative modeling, these large language models and so on. And at the same time, we're seeing a lot of challenges in environmental science, which is really challenging to address using conventional tools. And a lot of the challenges are, you know, to do with very large volumes of data, but also in my own specific field, we're interested in producing these very high resolution runs, which make a lot of data, but they're very slow actually, and they're very costly. They take a lot of power to run these runs. So how can we use AI to help us with these problems? And so I think this is just the time to be training up this new cohort of students who are ideally equipped to attack problems in environmental science with AI and have knowledge of both, which is really what you need to make progress.
Brilliant. Thank you, Anna. Laura.
Yeah, to comment, I guess, similarly to my colleagues here, I feel like in earth sciences, it's also the perfect time. So something we struggle with in earth sciences, well, just part of the field in general, is we often will go to a specific location and learn as much as we can about the physics-based processes that are driving what's going on at this specific volcano, at this specific glacier or ice sheet. And I feel like the timing piece right now is perfect for AI ML to allow us to take that location-specific physics-based knowledge and apply it worldwide. So an example I can give from my own research group is that there are a lot of open questions in glaciology, really basic science questions about how ice flows, how ice flow might change if it increases in temperature, if more water can access the bed of ice sheets and glaciers. So we, as a small community of glaciologists worldwide, go to locations, take detailed observations. There's not enough of us to really capture all of the rapidly changing cryosphere on Earth. But what we can do is take the physics of the processes that we learn in detail and try to apply them to our larger scale continental ice sheets. Yeah, so that's what excites me most. And in talking to my colleagues in earth sciences, we're kind of all similarly, we have this idea, we know this on the small scale. Could we scale this up if we had a brilliant student coming in to work with us that could pair AI and ML methods to these really rich data sets?
Great, thank you very much. Maybe just to add my personal take on this. So for my own research, we've worked a lot with big satellite data sets for a long time, and with fairly big climate model data sets for a long time. And it just felt like the progress is actually slowing down by the amount of data we're getting. We get more and more data, and we could never fully extract the full information content from it. And the traditional methods we had, they were good, and they were sound, and they're physics-based, and so all this is good, but they didn't deliver everything, and we just couldn't go as far as we wanted. And so more and more working in the area of these big data sets, I got excited by some of the possibilities that arise by machine learning and AI in our work. So specific applications include, we look, for example, for signatures of air pollution, not too dissimilar what Andrew just showed, for signatures of air pollution in satellite data. And we have a lot of satellite data. We have 20 years of data. You couldn't possibly look, say, for individual plumes in how air pollution changes cloud properties, which is an area that I'm interested in because it cools the Earth at the moment, and we don't know how much it cools in the future. And now we can basically run, once we trained a model to detect these features, we can run this through the whole satellite record, and we can do statistics, and we can gain insights we couldn't previously get. And like Hannah, we also have a strong interest in, making models faster, make them bigger and more interesting and more physics rich, and while incorporating AI in it. I think this is a good time now to move on, and I think we'll give you a brief overview of the training program in the CDT, and then Hannah will continue afterwards with an outline of the application process. What we haven't mentioned so far, but most of you found out already, we won't be able, due to the number of people, to have people answering questions live. So we will ask you instead to put your questions into the Q&A box. You can find a little button at the bottom. It says Q&A. You can click on it. You can put questions in. And importantly, you can also upvote questions, because we have quite a lot of questions and potentially limited time. So if you find a question really relevant, just upvote it. Don't write the same or similar question again. Upvote it, and then it bubbles to the top and will be answered as a priority. But now I hand over to Laura for the training.
Thanks, Philip. So yes, I'll talk briefly about what we have planned for the training program for this CDT. So as Philip and others have mentioned earlier in this open day, we have a goal and a vision that this CDT is both intrinsically interdisciplinary and very student-led. And what we mean by that is each student will be able to tailor both who they choose as advisors and what PhD project that they will pursue during the PhD through kind of and they will define these projects and peoples within the first year of the program. And so our teaching model really forms around our goal of we need to train a new generation of quantitative environmental data scientists who are equipped to make big contributions on these quite difficult problems, and at the end be prepared for a wide range of career paths. So how do we do that? The model we have for the teaching program, as I said, is tailored towards first training graduate students to become independent researchers. By the end of the CDT, you should be the expert on your topic and be kind of leading a path for future research in that direction. Because we have two different hypothesized streams of students coming into the CDT, we need to both introduce AI tools and frameworks, and at the same time, the environmental data sets and problems, and the introduction of these, both the AI and the environmental science basics, frameworks, and kind of groundwork will occur through taught material in tutorial-based or small group-based project work. Apart from that, there will also be a significant amount of interdisciplinary group work amongst the cohort to get together in things like hackathons to tackle grand challenges we have in environmental science and in the increasing complexity of AI. And then what does this training program look like in terms of what students would do in different years? In the first year of the training program is quite different from the following second, third, and fourth year. So in the first year, we have a vision that there would be in the first term core courses in foundations of AI and ML for the students coming in that have a more environmental science background. And for the students coming in that have more of a background in AI, ML, statistics, and maths, then there would be core courses for these students in environmental science areas. So that's already, you can see how kind of individually you might tailor what core courses do I want to take based on my background. Second, there'll be core skills training for the full cohort. For example, skills like programming and version control. As you move further into the first year, you move into more advanced cross-cohort courses, focusing on specific areas of AI or specific data sets or types of data that you might be interested in environmental scientists. So you're kind of focusing the coursework as you go through. And then towards the middle of this first year, you do kind of a tester 3-month research project supervised by one of your potential PhD supervisors to give yourself a chance to see if you like this project, will this be a good project for you to continue for the rest of the years. And then at the end of the first year, you will have defined who are my 2 PhD supervisors, what is my likely PhD topic going to be, and most likely what department will I transfer to for the remainder of the PhD program. Okay, and then on top of that, on the right-hand side, there's also just ongoing stuff in terms of training in all years of the CDT. So responsible AI training will form an intrinsic part of all courses in the program, whether that's core courses and advanced cross-cohort courses in year 1 or additional training that comes later. Also, we have a great Oxford Doctoral Training Center here, where you can take professional skills training courses such like scientific writing, communicating science, and specifically teaching skills training that's supported by Oxford's Developing Learning and Teaching program. So you'll be able to access that great resource for specific tailored training in all 4 years. And then the last 3 bullet points are, I think, some really fun things that will allow for a lot of collaboration and community building across the CDT, not just in individual cohort years, but in kind of all cohort years. So annually, we plan to have a cross-cohort hackathon, co-organized by one of our partners, Frontier Development Lab. And this will coincide with the cross-cohort CDT conference. Oh, and then this annual, 2-day CDT conference will provide opportunities for kind of everyone in the CDT to showcase their work, network amongst themselves, and maybe spin off collaborations. And then Philip mentioned this earlier, but we're planning to have a weekly seminar series, bringing the entire Oxford AI for Environment community together in the same room, and bringing in, leading UK and worldwide speakers to talk about, what's the latest challenges, opportunities, possibilities for tackling environmental problems with AI. You can find all this information on the Intelligent Earth website. And I think that's all I want to say about the program at this point.
Brilliant. Thank you very much, Laura. I think this was a really good overview already. And obviously, we're happy to answer any other questions you might have later. I mean, one thing I should add, because I'm excited about it. So one thing we're really keen on is to treat PhD students as grown-ups to some degree. You all have undergraduate degrees, you're mature people, and we want to provide something that's really useful. So instead of frontal teaching a lot where we just talk to you like in an undergraduate degree and you sort of go home and do your own bit, it's really this interaction that excites us. So we really think of, so you have a start, you have background reading, you have a bit of frontal teaching to provide the necessary background, but then you dig into real data and make it work for you. So I think that should be really interesting, but also it makes it really useful then later on as you do your PhD research. Because I saw already a question in the chat that someone said, I'm a data scientist, do I need to know how to handle satellite data? No, you don't, because we teach you how to do this. And you almost certainly, in one of these core courses that you have to do, you will basically get the tools to do this right away. And you work on it on data already. Great. I think this is a good time now to hand over to Hannah, who will tell us all more about how to apply to the program. And this, again, touches probably on quite a few questions that we already see in the Q&A.
Wonderful. Thank you, Philip. So let me share. Okay, you seeing the right one or the wrong one? The right one. Excellent. Great. So I hope that you are all now really excited about our Centre for Doctoral Training and are keen to apply. And so I'm going to tell you exactly how to do that. The first thing I want to say is that, the bulk of the information which I'm about to tell you can be found on our course page on the Oxford Admissions website. So this is the address of that page, but you can also find it linked from the Intelligent Earth web pages, or you can find it by searching for graduate courses on the Oxford website, www.ox.ac.uk. And you'll see there's a variety of different tabs here. And if you click on how to apply, it will go through the requirements that you need to complete to apply for the course and how you do it using our online system. So before you come to apply, I've got this short checklist of things that you might be thinking about. So the first one is you need to check your application fee status. I'm going to go through these in detail, so I'll go through them quickly now. You should think about potential supervisors. You should look through the online form that you need to fill out so you understand what information you're going to need to provide. Prepare the other documents that we ask for. Contact your referees, and you might be thinking about funding. So I'll say a few words about that again. Firstly, the application fee. I'm very sorry to say that we were going to require a £75 application fee for the course. This is something that is set by the Central University and not by us, and it covers administration of the graduate admissions. Having said that, we have this fee, we have a number of fee waiver schemes, and it's up to you to check if you are eligible for one of these. There's a fee waiver available for applicants from low-income countries. You'll find a list on the website. For refugees and displaced persons, for UK applicants from low-income backgrounds, and also applicants who've applied for one of our access programs recently and meet the criteria. So you need to check yourself to see if you're eligible for one of these, and you can indicate this in the web form if you are. We also don't require you to keep paying this £75 application fee if you want to apply for multiple related courses. So you can pay one fee and you can apply for up to 3 related courses in the same cycle. And we've got a list of related courses, but it should cover anything else that you might be interested in applying for. So for example, you can apply to a DPhil in one of the specific host departments, so atmospheric, oceanic, planetary physics, or biology, or geography, or so on, under the same fee. You can apply for one of the related CDTs, for example, the environment CDT, the NERC CDT, or one of the other AI CDTs. And so these are all covered under this fee. In order to activate this waiver, you have to request a code. But again, the instructions are on the website. So I hope that's clear. Okay, the second thing to think about is supervisors. And so I've seen a couple of questions about this in the chat. The problem is we are still spinning up our website, so please bear with us. But we have over 80 committed supervisors from across the host departments. And we're going to be updating our website with this list of supervisors within the next week or so. So please check back to see this list once it's been updated. In the meantime, if you're really keen to understand areas which you could work on within the CDT, then please look at the host departments for the kind of supervisors and their research topics. So we've seen specific questions in the chat about can I research agriculture and AI, or minerals and AI, or so on. So there you need to be looking in the host departments to see if there is that research expertise that we have that we could supervise you. As Laura's just told us, at the application stage, you do not have a supervisor assigned to you. So the idea is over that first year, you enter into conversation, a dialogue with a number of supervisors, both an environment and an AI supervisor, and you craft together a research project. And so that means you don't need to have a supervisor at application stage, or in fact, you shouldn't have a supervisor at application stage. And this means you don't need to contact anybody. However, having said this, it is really good to check for compatible interests. So if you know that you really want to work in a specific subfield of environmental science or AI, then do check that there are people available at Oxford who have similar interests, and have a few ideas of people who you could work with in your PhD. And while we've said you don't have to contact a supervisor, you can reach out to specific supervisors. So for example, if there are a couple of people you were really interested in working with, you could reach out to them and see if they would be accepting students, for example. Okay, the next bullet point I wanted to hit was the documents you need to prepare. So first document, a CV. You do not need to prepare a CV. We do not request you to upload a CV as part of the application. And that's because if you look at the application form, all of the information you would normally have on a CV, you enter into the form. So please do not upload a CV. The only document, in fact, that we do ask you to upload is what we call a statement of purpose. So this is a 500 to 1,000 word document, and it is not a research proposal. So here I've cut and pasted the description from our application website of what you should include in your statement of purpose. So the key thing here is highlighted. It should cover your motivation, your research interests, and your ambitions in the area of the CDT. And the kind of key is that you want to be hitting these bullet points in your application. So this is what we're going to be assessing your statement of purpose for. Your reasons for applying, your ability to present a coherent case for this, commitment to the subject beyond the requirements of the degree course, your preliminary knowledge of the subject area and research techniques. And note, this is preliminary knowledge. So it might be that you have more knowledge in one part than the other. So you may have more knowledge in AI and less in environmental science, or vice versa. This is completely expected and perfectly fine. Your reasoning ability and your ability to absorb new ideas. Now, I appreciate that this document might feel like a big challenge to many of you. Like, how could you go about crafting this document, and what kind of things should you include? So I'm going to spend a little bit more time talking about this document over the next few slides. So I've already indicated this list of what we're assessing for, but let me say a few more words. So, okay, firstly, we're very keen to assess what we believe your programmatic fit is, your fit to the program. Are you indicating that this interdisciplinary program spanning AI and environmental science is the right program for you? Also related to programmatic fit would be availability of supervisors. If you have stated that your key research interest is not an area where we have anyone in Oxford who would be able to supervise you, then that might be an indicator that this isn't the program for you, and we wouldn't really be able to support you in your research. We're interested in knowing your background knowledge, and so any prior experience that you have that's of relevance. So this could be through taught courses as part of your degree. It could be through extracurricular activities or work experience. So we're interested in understanding what your background is. We are also interested in understanding what your academic or your research potential is. So you may be able to demonstrate this. This is how we want to see that you will flourish on this program, that you will be able to really succeed in growing to be an independent researcher over the course of the PhD. And so what we're going to be looking for is if you have any experience which indicates that you have a good academic and research potential. And we're also interested in your career goals and ambitions. And this links back in again to the programmatic fit. Why is our Intelligent Earth CDT the right program for you in helping you reach your goals and ambitions? Okay, so some tips of how you might approach your statement of purpose. So the first tip is have a look through the application form, and particularly the page in which you basically enter your CV details, and work out what you've already mentioned there, and therefore what else you have left that you're going to need to put into this statement of purpose to make a really good case for why we should admit you onto the course. My next tip is to make sure that your statement of purpose is personal to you and specific to you. So in other words, what got you interested and motivated to apply to this course on AI in the environment? So as a way of giving an example of this without telling you what you should write, I'll give you an example from what we see in undergraduate physics admissions. And so many students write something like, I want to study physics so I can understand the world around me. And this is a very bland statement, and it doesn't actually highlight why that person is really interested in physics. A lot of people write this statement. Perhaps you could contrast this to an alternative statement. I've been interested in physics ever since my 6th grade teacher explained to me how a rainbow works. I went away and read up on refraction and so on and so on. The second sentence actually communicates why that person is interested in physics, whereas the first one is a very generic statement. So whatever you write, try and make it specific to you and explain why you want to apply to the program and what your goals are. Why is this course ideal for you? Communicate to us what your skill set is and the skill set you want to have at the end of the course, and why our CDT is ideal for this. Okay, tip 2. You're going to need to highlight your previous knowledge in this statement. So this could include courses of note from your undergraduate or master's degree, as well as any extra activities. Another one I particularly want to mention is for some of you, you may need to highlight your mathematical foundation, the kind of mathematical abilities you have. And that's because if you look on our website at our required other qualifications, we've already emphasized that we do require you to have some level of mathematical ability. And what we've said is, as a minimum, we would like you to have math skills equivalent to a UK A level, or to have done maths as part of your course. So you may need to highlight in your statement of purpose evidence to demonstrate that you have the mathematical skills that we require. Another statement is here: applicants whose previous degree was not explicitly quantitative should be able to demonstrate the ability to learn these quantitative skills. So please provide us with evidence to support these qualification requirements. If you have maths an A level or additional maths A level, if you've done a very quantitative degree, then you don't need to include this in your statement of purpose. We can see that from your qualifications. Another tip, please make your statement evidence-based. So don't make comments in your statement of purpose without backing them up. So for example, let's contrast the person who just states, I'm a fast learner, with the person who states, I'm a fast learner. For example, my master's research project involved using Fortran code. I went from a complete beginner to confidently editing the code within 2 weeks. The second statement provides us with an example of kind of why that person believes that they are a fast learner. You can also use examples from your CV and pull them into your statement of purpose to give evidence within your narrative. So let's say you don't have a background in environmental science. Courses of environmental science weren't offered within my degree program. So I sought out opportunities to learn more, for example, including a summer research project or attending an online course or so on. So please do feel free to pull over information from that CV to highlight things that you think are particularly of importance. And here I put CV in brackets because, as we've said, it's part of the online form. And then again, finally, you can use this as a place where you can give us more detail and examples from beyond this CV section of the form. So for example, you can give us more detail about any research projects that you've carried out, or you can give us more examples which demonstrate your aptitude for research, your potential for doing good research and to develop independence. So for example, from within a research project you've done, did you suggest or direct the research in any way or problem solve within that project? And finally, if you're thinking about specific, we'd like you to see that you're thinking about your future goals within the CDT and beyond the CDT. So give us, so here it's important that you communicate the ideas that you have about potential research themes and topics. And here, notice I've put themes and topics as opposed to specific projects. And that's because in the first year, as we've said, you will develop projects in collaboration with supervisors. So we're really looking for a thematic fit here, and explain to us, you know, how you've got this interest in these topics and how it fits in with your trajectory. You can highlight here supervisors and groups you might like to work with, but there's no commitment on either side at this stage. You can develop your interests during that first year. And you can also highlight your kind of future career trajectory and why you think the CDT is necessary. So I hope these few slides have given you a bit more of a feeling for the kind of things you can put in your statement of purpose and have helped you see the kind of things we might be looking for. This then brings me on to the next point, referees. So we require 3 referees. In general, these will likely be 3 academic referees, but you can also bring in a professional referee instead of one of those if you have work experience, but we do require at least 2 academic. Do recommend that you contact them prior to submission to check that they're happy to write you a reference. And we are requesting that your referees anonymize their references. So they don't refer to you by name, refer to your gender or ethnicity within the reference. This is as part of one of our EDI initiatives to minimize any possible unconscious bias that might come in within the admissions procedure. If your referee forgets to do this, then don't worry. We have the ability to go through and anonymize these ourselves before sending them out to the department, our colleagues here, to review them. But it would be very convenient if they would do this. And the final thing you might be thinking about is funding. As Philip has already said to you, this is a fully funded program, and so you will automatically be considered for a funded place. The one thing I want to add here is that in the application form, you will see some questions which are about nationality and things like this. And the purpose of these questions is to determine your eligibility for all funding options that are available. So both within the CDT, but also external, but within Oxford, which we might be able to bring in. And you are automatically considered for all those which you are eligible. So some examples of initiatives that we've partnered with are the Academic Futures Initiative, which is supporting underrepresented groups here in Oxford and providing scholarships, but also additional support for anyone who comes under that programme. So, for example, mentoring and training. The other initiative we're partnering with is the Africa Oxford Initiative. This is a cross-university programme, which is aiming to support researchers based in the university and their collaborations with universities in Africa. So we will automatically consider you for these scholarships if you are eligible. Okay, I wanted to now briefly show you the form. Here you see I've set myself up as an applicant, and you've got a number of tabs here which you need to fill out. So we're not going to go through them all by any means. So first tab, application type. This is where you indicate if you are going to need to pay the fee or not. So we can't see it's come off the bottom here. There's a simple tick box which you can check to say if you are going to need to pay the fee or if you have an exemption, and if so, why. The next page is the course page. Now, the thing to realize is that this application form is a standardized form for the university, and it is not bespoke for us. And so that's why some of these questions might seem a little odd, given what we're telling you. So, for example, here under course, you need to, it says proposed field and title of research project. We've just said you don't come in with a research project. So please, in this box, enter the theme from the CDT that you think you're most likely to want to work in. So whether that's core AI or climate or natural hazards or whatever it is, put that in here. The second box that we have here says proposed supervisors' names. As we said, you don't come in with a supervisor, so please leave that one blank. The next page we can look at here is about you. This is really the tab in which you enter information about your nationality. And as I said, this is only used to determine your fee status and also whether you are eligible for any of our other funding options in addition to the eligibility for the CDT funding. And it won't be used in any other way to assess your application. It's purely about funding options. Next one here, qualifications and experience. This is where you enter all the information that you would otherwise have put in your CV. If you scroll down on this page, you will also find an option to detail extenuating circumstances that will impact this application. So this could be things like problems that you've had in your career, your academic or your other career, because of COVID, because of caring responsibilities or bereavement or anything like this. And we do ask that these circumstances are current. So they're things that are affecting this application. So if it's something that happened a while ago and affected basically previous applications, say for your undergraduate or master's project, but somehow they have been addressed already, then you don't need to detail them again. But if you've got some current circumstances, please give us information about that here. And then lastly, I've got this page about supporting documents. So this is where you're going to upload, well, academic transcripts to give us information about your existing qualifications, but also your statement of purpose. And I want to re-emphasize, do not upload a separate CV here. We've got all the information on the qualifications tab, and do not upload a research proposal. That is not something that we are requesting as part of the application. So this brings me to the end of my presentation here, and I believe we are also moving on to a general Q&A from the panel now.
Brilliant. Well, thanks a lot, Hannah. This was extremely clear, in particular also the guidance of what not to do and not to write and how you can improve what you write in your statement. I thought it was really clear. It made me slightly nervous about previous application I've written myself. So this is super helpful. I think that's one thing I'd like to pick up on this theme as well, is because I think it's quite easy to mix up what we expect in terms of interdisciplinary from the applicants already. And that is, I think we're entirely open for people not to have an interdisciplinary training at this point. So you can be a hardcore biologist, or you can be a theoretical physicist, you can be a pure statistician, as long as you can demonstrate you're really keen to reach over and to be interested in this field. And obviously, as Hannah just mentioned, the more you evidence your interest, the better. But it's not that we require people to be perfectly interdisciplinary when they apply. Actually, we expect probably most of our applicants will be very disciplinary trained, because that's what you do in an undergraduate course. But you want to get to this interdisciplinary as part of this program. So you won't escape being interdisciplinary if you join this degree or this course, because that's exactly what we try to achieve, but you don't need to have it yet. So what we'll do, just what I want to outline for the rest of the time we have. So we'll start off with a general Q&A session, and that's with us. And then all of us on the CDT leadership will go in the background, and we have a fantastic group of students who volunteer to join afterwards, and to have a student panel discussion where you can ask students any questions you might have about the experience or anything else, the application, the program, and we'll be just in the background. And this, we won't take any record of this, so you can just ask also stupid questions. I think this is totally valid. And I would like to thank the students already who volunteered for that. But let's kick off with the general question and answer session. So we have lots of questions open, so we have to be relatively efficient. So I'll pick up one maybe, and then we'll just all chip in from all of us being there. So the top rated question at the moment is, how many slots will be allocated to non-UK students? To preface this, from us, we would like to have all of them open for everyone. But this is, we have an operational framework that we operate under, and it's funders and university and so on. So there will be, not all of the studentships will be available to non-UK students, but around a third of them will be. And we think that that is quite nice, but we obviously have ambitions to make it more, and we're actively working with partners to increase these numbers, but this is not an easy thing to do. Who wants to go next? I think we just go a little bit around and people can just pick up different questions, and you don't have to listen to me talking all the time. I'll pick one more then while people look at. I just reiterate, because Hannah already nicely outlined this. No, you do not need to contact supervisors before applying, but you can. And I think in particular, one thing is important, as Hannah said, it's important a little bit, particularly if you feel like you might be out of scope. So if you don't find any supervisor in an area you really want to work in, then it's probably unlikely that it's a perfect fit for the program. So in that sense, it's helpful, but you do not need to contact them. But many applicants find it interesting to have a chat about potential ideas beforehand. So it's up to you.
I can see a question here that's been upvoted quite a lot that says, are candidates evaluated more strongly on their depth of experience in math or AI and environmental sciences, or in the clarity of the project/area they want to work on? So I think this is something we've mentioned several times now. So we are not requesting a research project, a proposed project to be submitted. So the only way that we are evaluating you is on your past experience, for example, in maths or AI or environmental science, combined with an idea that you are within scope for the program. So we don't want a specific project, but we would like this indication, as Philip said, that there would be people here in Oxford who could support you.
Brilliant. I mean, the next related question is sort of how clear of a project idea do you have to have? And we exactly answered this. You do not have to have a clear project idea. We don't want a project proposal, but we want the motivation and evidence for your motivation to work in the space. And I'm seeing there's occasionally people raising their hands, so we won't be able to get you live. So please put your questions in the chat, and we still have quite a lot of questions, and we're trying to work us through it so that we can answer everything. I think there's a question, what can be, sorry. Go ahead, Laura.
There's a question, when will the full list of supervisors be available on the webpage? And so for that, we're hoping to have the 80 and 80 plus and growing list of supervisors on the website probably sometime next week or the week following. So certainly before the date of the application, and hopefully within kind of early December time. So keep an eye on the website. It is rapidly changing.
And that's a difficult question. And obviously the question that anyone would like to know in great detail, what can be expected in the interview? And there I'll be a little bit, not evasive, but I'll defer that to some degree. So we are working very hard to set this up in full detail. And obviously we have candidates from very different backgrounds. And we're working on a process that's as fair as possible to make sure that these questions don't favor people from any particular background. So we will publish more information on what can be expected in the interview around a month ahead of the interview. So expected by mid-January to be up, where we say, this is what you can expect in the interview. In the broad terms, we obviously won't tell you exactly the questions, but we will give you an idea how this is framed. I don't think we can be particularly more specific at this point, but be assured that you will have all the information and plenty of time to prepare.
There's a couple of questions related to applying for multiple courses. So there's one that says we can apply for 2 more courses. Is this automatic? Or do we need to find supervisors and reach out? Yes, no, that's not automatic. So if you would like to apply for additional courses, that's a completely separate endeavor from applying to us. So you should reach out separately. I suppose one comment is that many supervisors might take students from multiple courses. So if you've contacted a particular supervisor, they might advise you that they could receive you from one of multiple routes, but you would need to apply separately to the courses. And there's a kind of qualification on this fee exemption. Yes, you would pay it for one course, and then you request the exemption for the others, and you get sent a code which you can enter in the box for these other courses. Another clarification, if your interest falls under multiple course streams, then yes, please do state, say, the 2 streams that you're interested in that box I had indicated. That's perfectly fine for if you fall between kind of 2 neat categories.
Yes, I'll pick up several questions together, because I think there's a theme of questions emerging a little bit around the themes and what this means, and a little bit what's in scope, what isn't in scope. So these themes are a way of grouping thinking or grouping different backgrounds and approaches. There's no hard boundaries there. So don't worry exactly if you feel like, should I apply to this theme or the other? Say, take the natural hazards theme and the climate theme. There's a very large overlap. Lots of natural hazards are changing under climate change, and we're really interested in particular this interface. You will be able to select one or all, up to all themes in the applications. You can list them all. Don't worry too much at this point about it, but I think your core interest would be obviously really helpful to know. So we have a good sense of the spread of the interests. So yeah, don't worry too much about this. In terms of, there was a question about, say, AI for mining and so on. this is a slightly more complicated question. What's within scope and what isn't within scope? And I think it's partly in the title of the CDT. It's a Center for Doctoral Training in AI for the Environment. And what we're really keen is it's not everything that relates to the environment, which could be every field of biology, or it could be every field of many areas of physics. You can say, the environment isn't everything physics. It's really more specific to environmental questions and things that are relevant to the environment. So personally, I would think, so mining as an idea of exploration, extracting, is probably unlikely to be fully within scope, because that is not something we see unless it has an environmental link. And there could be, again, it could be sort of, if there's a clear link to, say, doing sustainable mining or finding sustainable resources. We'll look at this quite carefully, but we definitely want to stay in our mission. We have a purpose as AI for the environment, and it won't include all areas that are vaguely related. Say, non-Earth planets are also not within scope. It's not, say, clouds on a different planet. It's things that relate to climate on Earth. Any more questions to pick up from others? I've just talked, so I couldn't see it. And there's a theme of questions, or many people were interested, if you have a background in AI machine learning, what are the determining factors? To some degree, that was nicely contained in Hannah's presentation, together with the fact that it's totally fine to be disciplinary up to this point, demonstrate you're interested to work interdisciplinary, and really you can do this in this statement of purpose quite nicely.
I've seen a couple of questions about referees. An academic referee is someone commenting on your qualifications. So if you have somebody who can comment on, for example, a project that you might have done within your undergraduate or your master's. If you are currently working in a company, and even if it's a research company, then that's a professional reference. And others can chip in with more qualifications.
So there's a question around, is it possible to do a master's in the program? No, we don't have a standalone master's program here. I mean, the question is, how is there a way to get involved as a master's student? So if you're part in an existing master's student here in Oxford, then we will share resources and make some training potentially available. We have to, obviously, we have to sort of keep things within limits, but there won't be a separate standalone master's as part of this program. But we see this program as a center of a community growing in the space, and say our master's projects we offer, say in the physics department, can very well see to be strongly aligned with some of our activities, but there won't be a standalone master's. And I think there's an important question that some people may wonder who have a week of open days this week. So what's the difference now between people applying to the DTP in environmental research at Oxford and the Intelligent Earth CDT? And there's no strictly hard boundary between this, but I think all projects in this Intelligent Earth CDT will have an AI machine learning focus and element, and will have a strong training in it, and will be quantitative in that area. So keeping in mind that it's more than just applying a black box tool. I think in the DTP, but that doesn't mean that in the CDT we're still totally focused on the core science underpinning it. It's a tool, but it's not necessarily on its own replacing the science. In the DTP, you can see a project with a certain science focus where AI is one of the tools that's being used, but probably in a less advanced sense, or people won't have the full in-depth training, and people are not expected potentially to demonstrate that they change and dig deeper into the AI. But I think that it's entirely allowable in the DTP to work with an AI tool. And so there's some overlap in some respect. What we expect to, it's not impossible to foresee a future where we also cross-refer a little bit projects. And one thing we definitely do, we'll share some resources, But given the intensity of the CDT training program, it won't be possible for a DTP student to attend all the training we offer.
Cool. I'll just take a question on, like, what does the AI stream look like? And the answer really is it's to try and cover the core fundamentals of machine learning and being able to move a little bit beyond just application of existing open source tools, but to also be able to refine and develop them more specifically for your particular application. And that said, within this, we've said that we have these kind of two entry streams, one kind of more from the environmental sciences with AI, and one more from AI, then shifting into environmental sciences. So depending on where you sit in your kind of past background and level of interest and experience, you might explore deeper AI kind of topics if you are more focused on the AI area, and then expand outwards onto applications of that.
Okay, there's a question on, will the center have an interest in AI modeling of the broader sustainability problem in interactions between policies, economy, ecological systems, or is it more bounded in the natural sciences? So I think broadly it sits more squarely in the natural sciences, but there will be always some overlap. And we have, for example, an environmental solutions theme that deals, is slightly out of the environmental science question itself. It can be things like material discovery for carbon capture. It can be related to a wide range of solutions. We don't see too much going into the social sciences because it's just not the focus of this program. The focus is an AI for the environment, but we see a lot of interactions with the social sciences. So we'll work actually also with the Institute for Ethics in AI in our Responsible AI program. We will have definitely many sort of joint activities, but we don't see the PhD projects themselves to be social science projects or economy-based projects.
Okay, and then there's another question about kind of crossover with other DPhil students in other DTPs and CDTs. Yes, we intend to kind of bring all of these cohorts together. So, for example, in the AIMS CDT shares a lot of overlap with the machine learning aspect of this program. So we will try and have joint conferences or activities to bring the cohorts together.
I've seen a range of questions. I'll address one after the other. Someone asked about taking existing modules as part of the training. Yep, we will provide a range of modules which you can choose from. If you don't see what you need as part of your bespoke training pathway, then you can take existing modules or audit those modules in other departments. There's then a number of questions related to I would say inclusivity issues. So there's one which says, there's two I've seen which are related to age. Is there an age limit, or will applicants with a long career potential ahead of them be an advantage versus those making a mid-career change? Age is not something that we will take into account when we admit to this program. There is no upper age limit. So please, we encourage you to apply. I've also seen one which was about in-person attendance. Let me just find it again. I've lost it. What level of in-person attendance is required for the various phases of the course? I have young children, so might need some flexibility and or remote study in order to do my parental duties. So we're very keen that this program be inclusive and accessible to everybody, including those with parental responsibility. And so we would work with you to ensure that you could still study. There would be some in-person attendance that's needed, but where possible, we would put this in a kind of core hours so that you'd be able to, say, leave to collect your children from school and so on. So I think we would strongly encourage you to apply, even if you have these other caring responsibilities.
Great. I think an important question people ask, will interviews be in person? And the answer is no, we will do virtual interviews. Most Oxford interviews have gone for virtual interviews, and they make it much easier for candidates to access.
There's quite a few about partners, Philip. I don't know if you want to take that.
I missed them. I'd be very happy to take them. I just haven't seen them. Can you paraphrase? And I'm happy to chip in.
Things like, can we bring, if we have contacts in other organizations, can we bring them on as a partner? Or if we've already worked somewhere like BAS, the British Antarctic Survey, could we have them as a partner? What is the scope of a non-academic partner? Is it like working as an intern, or is it more like a supervisor? Questions like this.
Yeah, these are good questions, and this will evolve to some degree. So we are in a stage where we actively onboarding partners still, and we obviously have to keep it within manageable limits, but there's a lot of interest, and we're really interested to make the student experience as positive as possible. So in principle, we're quite open. I hope to separate this process to some degree from the application itself, in the sense that we wouldn't want to favor any applicant because they have links to a partner over someone who doesn't have link to a partner, because it would not be a level playing field. But I think we're very happy to engage in discussions with potential partners. In terms of what's the role of the partners, I think this will be really a little bit specific to each project, and we will do a matchmaking with students, with projects, with the supervisors and partners in the first 2 terms. And some partners will be potentially extremely involved. So some partners may want to join weekly meetings with the students and the supervisors, and other partners may not have the capacity to do this. So there will be a variety of things, but all of them will be actively involved. And there's some partners have slightly different roles, like we're working with, say, Frontier Development Lab, who in particular will be involved in our hackathons and so on. So there's no single answer to the question what exactly what the partners do, because it will depend on the project. But I think in any case, they will enrich a student experience quite a bit. And there will be a complicated process for us to do this matchmaking between partners, supervisors, and students. I think it will heavily involve sort of just also the research interests or the scientific interests of the partners and how this matches onto the project. So I think it's not guaranteed if someone applies with a certain partner in mind that this is the perfect match they will get. So it's not we can't guarantee. And likewise with supervisors, we have many great supervisors on board, but we can't guarantee that exactly you end up with a supervisor, because there might be several students wanting to work with the same supervisor. So there is a matchmaking process, and we'll work to be really fair and transparent about this in the first 2 terms. I see our questions are not getting less. We're very happily answering questions, but you're asking many great questions, and we're not getting less. So what I suggest maybe is to pick maybe a few more questions, and then while we hand over to the student takeover of the panel, we can maybe answer the rest of the questions in writing. A few of us, we can just try to answer them all. But I hope we get through the full list, because the list doesn't get any shorter. Are there any bigger themes still outstanding that any of my colleagues have picked up that we should have mentioned in person?
There is a question, what is the main career path of the CDT program graduate? Is it academia, industry, something else? And I don't know, my answer to that would be it's entirely up to you, what your career path is after the CDT. And I think we've organized the training program, and then you can kind of self-organize your PhD interest to be to set yourself up really well to join a variety of kind of future career streams. I don't know if others have opinions on that, but I feel like this is a very open or not constricted to producing future academics type CDT.
No, I think you answered this perfectly. I mean, the world is at your feet to some degree. I think we expect you should be trained to make real impact in a real wide range of career paths. And it's important to point out that for a PhD student, the academia is not the only career path. There's a vast range of options. We expect actually the graduates of this program to be highly sought after. So I hope it's just a very positive experience afterwards. Okay, but I think we're probably at a good point where we answered the key questions, and we'll work in writing in the background. And I'd like to now invite the students to come aboard and turn the cameras on, and we will go in the background. And basically, okay, the only smaller problem I hadn't foreseen, and I'm thinking out loud as we do it, because we still have many unanswered questions in the chat, that the students will find it a bit harder to find the questions. What I could do for now is I sort the questions by being most recent. Then I think we initially see up the student questions coming up rather than sorting by the most upvoted questions. And I hope that works for the student panel. But can I now ask you all on board and maybe to introduce yourself, and then we really don't want to micromanage this, so we hand over to you to answer any questions. One of you can take the lead and chair. I'll ask you to introduce, and then I hand over to you. So I'll just go by whoever pops up on the screen. So Greta, do you want to start off?
Yeah, sure. Hi, I'm Greta. I'm a third-year PhD student in atmospheric, oceanic, and planetary physics. So that's like a subdepartment of the physics department. And I'm part of the NERC DTP program. So that's the other environmental DTP that is currently happening at Oxford. And my research is on machine learning for atmospheric convection. So trying to improve how clouds are represented in weather and climate models.
Great, thanks. Vid, you're next.
Hey, hello everyone. My name is Vid Ružička. I'm a PhD student here in my 4th year right now. I'm supervised by Andrew Markham, so ask me anything. I'm working on detecting methane signals inside hyperspectral data of satellites and sort of this remote sensing area as well, but mostly actually trying to do research on the AI side. So,
brilliant, thanks. Lily.
Yeah, hi, I'm Lily. I'm a 2nd-year PhD student, also on the NERC Environmental Research DTP. And like Greta, I'm in atmospheric, oceanic, and planetary physics, and I'm using machine learning to evaluate storm resolving climate models. And yeah, happy to answer any questions.
Thank you, Lily. Thomas.
Yeah, hi, I am a 2nd-year PhD student with the engineering science, or within engineering science. I'm in the environmental fluids group, and my research looks at taking scientific machine learning and using it to improve the spatial and temporal predictability of tides, and applying that to storm surge modeling, tidal energy, and then looking at anthropogenic drivers of change there.
Brilliant, thanks. Leo.
Hi, I'm Leo. I'm a 3rd-year PhD student with DYT in the Department of Statistics, and I work more on the fundamental core AI for science method developments side.
Brilliant, thank you. And I'm not sure I get your pronunciation right.
Oh,
Yuan?
Yeah. Thanks. And I'm a 2nd-year student here, DPhil students in computer science, and my supervisor is Andrew Markham. Yeah, and I focus on some AI applications, such as sensor-based data mining and some time series, and also some signal enhancement and classification, localization, something like that. Yeah, thanks.
Brilliant, thanks. So what I suggest for us from the academics, we just go in the background, we turn our camera off, and we hand over to you. And I hope there's not too much confusion on old question versus new questions in the Q&A. But otherwise, just feel free to answer anything you find is most relevant to you and discuss among yourselves.
I saw one earlier that related to, it was asking whether the result of the research would be in developing some type of practical application or leveraging AI to generate kind of new ecological insights. And I don't know, my opinion of that is that I don't think that those two are mutually exclusive. And I think that in general, you find that by improving the predictability of something, you can also find some type of insight from that. And I think one of the interesting areas of environmental intelligence is kind of closing the loop between we can generate better predictions and then we can use it to understand why we're generating predictions in the first place.
I see one question that says is there any time that students should stay in a different university, for example, Germany or the US? And I do think that there are opportunities for this. In a way, it's encouraged to just kind of increase your collaborations and stuff. But like depending on your specific project and obviously talking with your supervisor, I do think that there's, at least in my program, like opportunities to possibly go work with other universities or research centers, either in the UK or outside of the UK.
There was a question if your topic has changed since the idea you applied with. Absolutely, yes. It made a 180 in the first year. So yeah, it kind of sometimes delays things, and I have seen other PhD students also like being a little bit delayed because of this. But I think this just happens. You don't know what will happen in that research as well, right? So.
I saw a question for Greta and I that was asking about our background, although that's probably, as the person asking the question said, relevant to everyone as well. My background is actually in computer science, which is probably quite similar to a lot of people on this call. And so, yeah, I did an undergrad and master's in informatics, and then kind of got here and I'm now learning the physics and kind of the climate science part of my project. But I don't know if you want to talk about your background, Greta. But yeah, generally people kind of come in from a variety of different backgrounds.
Yeah, I agree with what Lily said. I think people come in from various different backgrounds. My background is in civil and environmental engineering, but with like a focus on water and climate science. And so, yeah, I think kind of as you do your PhD, you can kind of use some of the skills from your background and then combine that with like new things where you might need to learn some things in a new research area as well.
There are a couple of questions about like life as a PhD student here at Oxford, and how does it look? How long do you generally work? So I think this may probably differ for different people. I like there is this like metaphor that this is not like a very fast run to achieve something, but it's a marathon sort of. So you have to learn to pace yourself. So some days, just personally, right? If I'm able to work and think very like focusedly, 2 hours of like really focused work is enough for me, and then okay, I did my task for that day. I don't know how this is for the rest of you. Yeah, I mean, obviously I try to work longer and stuff, but you know, like sometimes it just doesn't work out the brain. So what about you? Oh, Michael, I think we don't hear you.
I don't think we can hear you.
Do you hear me now?
Yes.
Fantastic. Hi, sorry, I'm Michael. I'm a 4th year StatML CDT student. I work on like geometric and machine learning and equivariant machine learning, mainly doing method development, but with applications in science problems like chemistry and biology. But I just want to say, yeah, like similarly, like if I'm doing quite intense math stuff where I really have to think, I can't work like a 10-hour day. It just doesn't work. But if I'm like writing code, then yeah, I tend to work a bit longer, but it sort of depends on what you're doing. If you're writing up or you're doing something that's slightly lower taxing on the brain, then you can work a bit longer, but it's definitely worth like preserving your mental energy, because if you keep grinding out very long days, your productivity drops through the floor, I find anyway. Certainly having a hobby to do that isn't work is very, very beneficial.
Yeah, maybe as same as me, maybe because I usually I spend maybe 7 or 8 hours per day in weekdays. But maybe if there is a conference deadline, maybe I will work 10 more hours. Yeah, maybe. Yeah.
Sure. I think there's also like a couple of questions on like what life is like, you know, how close knit are the cohorts, how much time do you spend in college versus department and this kind of stuff. I think that's very much a your preference thing. Like some parts of my CDT cohort are very tight knit, and then there's some people who kind of just fell away after the first year. And the same with college versus department. Like I think most people choose like 1 or 2 places to make their social centers in Oxford, and there's too many to kind of commit to all of them. So some people choose college, some people choose department, some choose their course. You know, it's quite whatever you make out of it, really.
Yeah, I agree with what Michael said. I think especially in the first year, I found it really nice to have a cohort because you kind of get grouped together with people that are in the same position as you, are just kind of getting used to life here, and are setting up their projects. And so it's really helpful to kind of have a community there. And then yeah, I personally don't spend I'm in Reuben College, and so we got our building this year, and so it's kind of changed how much time I spend there, and I now go there for lunch quite a lot, which is really nice. And there's a lot of opportunities to get involved in, but it's very much up to you. And there's kind of sports that you can do through college, which I know a lot of people really enjoy. So it's nice that there's a lot of offers, and then it just kind of depends on what you like to do, which ones you end up taking up.
I think there's also a question about like, does the stipend that you're paid cover your living costs in Oxford? I think for the most part it does. The UKRI ones are pretty okay on that front. You might want to pick up like teaching work and stuff for a little bit of extra money, but I think most people can get by on the stipend that's paid.
Slightly related to this, because I saw a few questions popping up, is whether or not we have to do any teaching. I mean, I can only say what it's like on the NERC DTP, but I'm assuming it'll be quite similar on the CDT, which is that there's no required teaching. So yeah, you don't have to teach, but the option is there, which is a nice way. If you want to do kind of some demonstrating for a few hours a week, it's a nice way also to earn some extra money and get some good experience. And so, yeah, I think quite a lot of people do like small teaching jobs.
I would like to add like one small thing with the teaching. I think there is also like it's I found out that I quite like teaching because of basically these experiences. And if you kind of want to follow up on that path, there are some like small trainings courses that are there for the PhD students and probably CTs too, I think. So you can kind of join a course which will have you, while you are teaching, try to analyze what you are doing and how you are teaching and everything. And it's actually, you get some small certificate at the end as well. So there are some like ways of supporting these activities too.
Yeah, I think it slightly depends on your department as well, because stats, it's not 100% required, but they really want students to teach because we struggle to fill the teaching quota. So it does depend a bit on which department you end up in as well, I think. If you're in like maths, I think it's not compulsory, but like stats is so small that we typically have to do a bit more teaching.
And there's a question about are most of PhD students starting directly after their master undergrad degree, or are there many people who start after working? Maybe most of us are starting directly after the master or undergraduate degree, maybe. But maybe after working, you have more perspective and maybe more ideas about your research field. So it's not a bad thing, and I think it's not will have not impact on your application and your interview, maybe. Yeah.
I saw one question about, is it possible to get it done in 3 years if you already have a master's degree? Like, to some extent, yes, and to a lot of extent, like things like pacing and how much work you do, these are all really down to you. Like a PhD is much more of a self-driven process than something like a master's. Like you can get a PhD done in 3 years if like everything works out fine and you get some lucky breaks in your research and stuff like this. I mean, the only requirement to get a PhD is that you submit a thesis and pass your viva to some degree. So if you can get it done in 3, you can get it done in 3, but that really depends on if like your research works out luckily and how much time you spend at it, I think.
I think
Go ahead, Lily.
sorry. Okay. To add to that, I mean, we're not on the CDT because it's a new program, but the way it worked for us is that in the first year, you're very much kind of focused on training and kind of setting up your project in a discussion with supervisors. And so it's kind of depending on, I think there's another like 3-month project for the CDT, if I saw that right on the website. You'd only really start with your PhD project kind of towards the end of your first year. And so it's a 4-year program, but you're not actually working on your PhD in the first year, roughly. And so I think that's why that's kind of the time frame that is set. But it's definitely right that it very much kind of depends on the person and how you approach your project.
Yeah, I was also going to kind of reiterate what Lily said, and then also just mention that of like the people that I know, I don't know anyone that's finished early, if that gives any indication. But people do, you don't necessarily have to finish in like exactly 3 or exactly 4. People are kind of like doing their vivas and graduating at any time. So there's not like a strict 3-year or 4-year cutoff as well.
I saw one about how the kind of balance works when you have supervisors from seemingly disparate fields. So my advisory core is kind of within the environmental fluid mechanics group, but then also have an external one in machine learning. And so generally it's interfacing with whatever your core group is, but then when you have questions and maybe need more assistance externally, then you would go and for example, I'm not an expert in machine learning. When I need help with the real core AI stuff I'm doing, I go to Steve Roberts. But in general, the day-to-day is spent with my kind of core advisors.
There's a question about, do you have time for hobbies and going on vacation? Yeah, for sure. I think I take maybe like a month off a year total, like of like maybe 25-30 days off a year. I mean, the university says there's a guideline which is I think taking 28 days or 30 days including bank holidays completely off, like similar to like a normal job in the UK. And in terms of hobbies, yeah, I mean, Tom and I both spend quite a lot of time down at the river rowing. Plenty of friends do lots of other extracurricular stuff, and more importantly, I would say it's really important to remember to do those things. A lot of people semi-burn out in their first year because they quit hobbies and spend all their time working on the PhD. But I think by 4th year, most people realize that like you can't really do that level of intensity all the time without something to break up your life.
There are a couple of questions about like how is it to join this very high-paced environment, and also there was a previous question where like if this environment is quite competitive between the students. So I think the competitiveness is there if more so in the kind of earlier programs. So I think the bachelor and masters, because I think there is a bit more competition. But at least from my experience, I found this the PhD environment here that it's much more supportive. Basically, people are not really like fighting for marks or anything at that time, and I think it's quite common also to within your own lab or group or whatever to find people to like do collaboration with, or even if you are not necessarily collaborating on the same research project, just kind of share ideas. So it in theory is quite like competitive, but actually I don't feel stressed from those reasons. Kind of on the other hand, the students, the fellow students in my program are there to kind of help me with like, okay, we are all facing with the same transfer of status and then confirmation of status and so some like technical things that we need to figure out, and there is support for that, I think. So
yeah, I think for sure to echo that, like you don't come out of PhD with a mark, you come out with a PhD, right? So there's no fight to be the first person in the mark list, right? And then really it switches from being like, oh, I need to come out first in my year to like, well, actually what I want is my group to be well recognized, so that when I graduate, and for me to have good recognition as well, so that when I graduate, you know, people recognize my lab as a good lab, they recognize my name as a good name. And that really is done by working well with other people more than fighting other people and like jealously hoarding secrets and stuff like this. So it's a complete turnaround from undergrad and masters.
Yeah, and maybe sometimes you will cooperate with a paper and maybe a project with your lab's members, and so it's useful if you connect with your lab's members, not maybe fight with each other.
I think it depends probably, like I'm much more on the machine learning spectrum of this, where like almost you get very, very few papers that aren't co-authored. You know, most papers are 4+ people. It's a very, very collaborative environment, especially on the machine learning end of things. There's a question, do we work weekends regularly? I certainly don't. I don't know about the other panelists.
If there are deadlines.
Yeah, if there's deadlines, yeah, but other than that.
There's another kind of few questions, I think, asking why we chose to apply to a DTP rather than a traditional default. And so for me, it was, for one, that I really liked that the kind of flexibility that you didn't have to have like what a project set in stone, and you could kind of get there and then together with your supervisors develop your project idea. And yeah, that it was kind of a lot more flexible at the beginning. And then because my background was in computer science, what I also found really useful is that you have the chance to take courses in the beginning, and that it kind of, you know, starts with a focus on training, giving you the chance to learn kind of the bits that you don't yet know that will be really useful for a PhD. And then, as I said earlier as well, I think the being in a cohort and having that community is really useful. And so, yeah, so looking back, it definitely was a good decision for me. I don't know if anyone else wants to speak on that as well.
Yeah, just to add in on that, I think that like picking a supervisor is one of the most important parts of your PhD in general, and how happy you're going to be during your PhD and how your PhD ends up. And so I think it's kind of cool with like the CDT program that you get to go in, not necessarily like already having decided on a supervisor who you might not know very well at that point, but kind of get to talk to different supervisors, do a mini project with one of them, and kind of get to know them better before you pick a final PhD project and supervisor.
Just because I've seen it a few times now, there's a question about like, how many papers do you need to publish before graduating? Like, is that a requirement on this front or something? Certainly, I don't think there's a requirement. Like, there's no one says, you know, you have to have X numbers of published papers. On the machine learning end of stuff, like, I think 3-ish would be normal, like, requirement to build a thesis. You probably want to put about 3 papers in there, maybe a bit more. But that's not required. That work doesn't need to have been published. It could just be written up. But I would say most people come out with 3 or a few more on the machine learning end. But maybe some of the environmental people give a perspective on that.
It's the same in the engineering group as well.
Same in computer sciences. There was a question about what's the process of selecting the research topic, and is it possible to collaborate with the supervisor if you kind of pivot away into a topic that is not his own necessarily? So I am myself in a regular DPhil. I'm not in the CDT program, but actually I am now in my 4th year. So like I probably made this in a way that like I would have benefited from something like a CDT, because I think having the 1 year to like really blunder around and find it or like search for the topic is super good. Especially if you don't really have like a super solid idea at the beginning, or even if you have it and then during the first year you realize, oh, actually people have done stuff there and it's like really, I don't know, super competitive, and maybe all the idea you had maybe is done as well. So I was kind of pivoting in my first year, and my supervisor Andrew Markham was kind of very nice in this process, and he did the stuff I'm doing now. Satellites is not necessarily his thing, but I think he always like brings in his kind of like focus on processing data from sensors, and so like sort of sensor focused approach to something else that I'm kind of like trying to think about. And I think there is often something kind of interesting that happens there, that like the ideas I wouldn't have, he has, and it's asking me those tricky questions. I'm like, okay, goddamn, okay, I've not thought about that. So it is useful, even if it's not exactly the same topic as his. So another question about, oh yeah, sorry.
Yeah, so there's a few about picking colleges. I don't know if anyone has any insight on that. Some colleges have more money than other colleges. This is like an unfortunate truth, which means that while in theory all colleges are sort of roughly the same, you might find getting like travel grants or equipment grants a bit easier through different colleges. Generically, the older, more central colleges have a bit more money, but that's not to say that like newer colleges are not worth going to. Some of them also have very generous grants and stuff. Like Wolfson has, I think, really good graduate support and stuff like this. So it sort of doesn't matter, and it sort of does, I think, is the answer.
And besides the money as well, there's also kind of, I don't know, I guess slightly maybe different cultures and different colleges. I mean, some are more international, some less so. Some have undergrad students, so there might be more social events that focus on those undergrad students versus grad students. But then there might also be like more mentoring opportunities or teaching opportunities if you're in an undergrad college. So there's kind of pros and cons to all of them.
Yeah.
Maybe some. Oh, sorry.
No, you go.
Oh, yeah. Maybe some college have their own have their main field, such as I'm in Merton. So Merton, maybe most of the students in Merton, especially for the graduate students, they are focused on the economy and the history and education and something like that. Yeah, maybe Cable or Wolfson, Ruben, they will more focus on the engineering and computer science. Yeah.
Yeah, I don't think that should affect your choice too much, though. I mean, there's quite a good spread of all the disciplines, I think.
And I also think it's so difficult to find that out when you're applying, and there are 40 different choices.
Yeah. There's a question about being based in Oxford. I believe the requirement is you have to live, it's a very archaic rule, you have to live within 3 miles of the central church of Oxford for at least 6 terms during your PhD, I think, if that's correct. Yeah, I think it's 6. There was a COVID reduction for that, but I think it's still 6. So if you're on a 4-year course, that means for at least half of your time here, you need to be in Oxford. Yes, I think. I mean, I think you can get exceptions for this if there's some like real extenuating circumstances and stuff. But yeah, I think the expectation is that you will be in Oxford. And I would say you will benefit a lot more from being in Oxford than trying to do a PhD remotely. Like, there's so much intangible benefit from like having coffee with lab mates and talking about ideas and meeting people from lots of different disciplines.
Yeah, just to add on to that, I think there's a few people in our department that, for example, live a bit further away, for example, in London, because their family is there. And so I think there's always, if there's any circumstances that require you not to live in Oxford, there's ways to accommodate for that. But they still, even people based in London, commute in multiple times a week, because it really does kind of make a difference to be here in person.
There's a rush of cost of living questions at the minute as well. So is housing difficult to find? Is it expensive? What's the cost of living in Oxford like other places nearby? Oxford is one of the more expensive cities in the UK. Housing, I don't think I've not known anyone who's had like real trouble finding housing. but it can be a little bit more expensive than you might want it to be, I think. So I think there's generally enough capacity. And certainly in your first year, most colleges accommodate students, I think. So you won't have to worry about that, in the first year when you arrive. And then usually in the first year, you meet a bunch of people, you choose to live with them. The next year, you sort out a house. The housing market is quite cyclical, though. So, like, especially for student housing, most contracts start in September, end the end of, the next September. And there's kind of quite a cycle in the market where, like, suddenly all the properties come on to be rented, and then the numbers available drop off after that. It's not impossible to find stuff outside of the kind of peak window, which is, I guess, January to March probably is like the peak window for renting a place for the next year. You can certainly find stuff after that. It's just there's a lot more choice in that window. So a bit unlike London or a normal city, Oxford is very, very student heavy. So that the housing market is affected by that.
There's a question about the interview. Maybe do you guys have any tips on the application and interview process? Yes, maybe when I did the interview, I just send an email to my supervisors and ask how long time is it, and what's maybe is there anything I need to prepare before the interview, and I just prepare our interview just maybe 40 minutes or 45 minutes about that, and I just prepare 8 or 9 pages slides for that, and just list my education background and also my previous some projects, and also if you have some published paper, you can also mention it. Yeah, and after that, just answer their questions, some theoretical questions, and also some project related questions, such as what's your research proposal? Yeah, something like that. Yeah.
On the complete other side of that, I would say be genuine, be honest, and be excited. You're going to have to work on this project for 4 years, and the people interviewing you, if they admit you to the CDT, will have to work with you for 4 years. So more than like an undergrad interview or a master's interview where, you really don't have to interact with the people who admit you. People are looking for you to be part of their group, to be part of their reputation, and to be good people to work with for 4 years. So I think that's a significant other thing to consider, is that, like, much more like a job interview, come across as just a decent person, because if people don't want to work with you, that's going to affect things.
Yeah, I think my interview was a bit different to what was just described, because we didn't have to prepare a presentation, and that's usually something that you will find out. So when you get your interview offer, they will tell you if you're expected to prepare any formal presentation or anything, or if it will just kind of be more like a conversation-based interview. And then, yeah, kind of what everyone has already said, but it's kind of be ready to talk about your background, maybe some previous research experience, just kind of anything that you mentioned in your application that could be interesting, that people might have follow-up questions on. Yeah.
Yeah. There's a few questions coming through about like diversity and international students in Oxford.
Yeah, maybe I can ask. I can have such as for the international students, because I'm an international student here, and there are many students scholarships such as our CDT and UKRI, and also there are some scholarship from maybe your department, your college, and maybe your country. Yeah, because I'm from China, so I will have some other scholarship from my government, my country. And also we can apply some scholarship from our university, such as a Clarendon Clarendon scholarship. Yeah, something like that. And we have many opportunities about the scholarship. Yeah, not especially for the international students, but also for the global students. Yeah.
Yeah, I also think the majority of the students here today are international, if I'm not mistaken. And so I think that kind of shows you that it is a very international community, which yeah, I think is really nice. And then for scholarships, I think the university website is really useful. There's kind of a list of anything that could be relevant, and so it takes quite a while to get through. But if there's, I think for some you kind of have to send some additional application documents in. So it's definitely useful to kind of have a look at that.
There's been quite a lot of people asking about like internships and like in academic visits to other universities. Like for myself, I did an academic visit for several months, and I've done quite a few internships. So from my perspective, yeah, definitely there's opportunities. I'm on the more machine learning end, so I've interned in more machine learning kind of places. But those options are super available. And academic visits, I think, yeah, that's very doable. The funding is the tricky part. So if you have money to go somewhere else from somewhere, then it's very doable. Most places are really happy to host you. If you need money to go somewhere from the institution you're visiting, it's a lot harder typically. But particularly American universities sometimes have that money available. These things won't be advertised. You just need to get in contact with the groups on the other end, and just say, hey, do you have anything?
I also think I saw on the CDT website that there's a secondment planned for all students with their kind of industrial partner. So I think there's kind of, there's a specific format for an internship that's kind of already planned as part of your PhD, which will probably be really useful because that'll kind of be fairly easy to organize. But yeah, in addition to that, a lot of people are able to kind of pause their PhD for a few months to do internships kind of over the summer. And so there's lots of opportunities.
I will just mention though that international students might have a slightly more restrictive internship opportunity, because as an international student, if you officially suspend your visa or your student status, then you have to like renew your visa and stuff. So it gets tricky. So as long as your internship is like related to your PhD and part of your PhD, then it's fine. But there might be slightly less scope beyond that. There's also a few questions on selecting supervisors. And I would just say like a few things. One is like, make sure your research interests align, but then also possibly like working style. Like, so for example, if you're really hands-on and like want a supervisor who's really engaged versus like a supervisor, maybe you work super independently and it might not need as much input like weekly from your supervisor. So kind of just seeing where like your working style also kind of aligns with what your supervisor can provide.
Yeah, I mean, with that, there is the tip of trying to ask the PhD students of that supervisor how this person is to work with. That sometimes works as well. Some people reply.
Yeah, I think it's helpful for talking to the supervisors, and then also talking to students in their groups as well is also really helpful to just kind of get an idea of the group culture as well.
There was a question about what's called imposter syndrome. I think we all have it as well, despite being here for several years. But because everyone knows about it, then it becomes easier, I guess. But yeah, I don't know. What is your guys' opinion on that?
I think talking about it, yeah, like there's no longer a culture, I think, of having to bottle that kind of stuff up. Like you can, your cohort mates will be feeling it. You can talk to them about it. Yeah, I don't think anyone ever quite feels like they live up to the Oxford reputation, but I think it requires a bit of a mindset shift from like, am I living up to it to am I living up to the best job I could be doing? So I think as long as you can satisfy yourself that what you're doing is the best you can be doing, with all the caveats about like you need to obviously take breaks, because if you don't take breaks, you'll get, you won't do as well. So yeah, I think shifting it to like, am I doing the best that I can be doing in this position? Like, other people have got me here, other people have chosen me to be here. And so if I believe in them and then do the work myself, everything should work out.
It's a quick question on, can you choose to live in colleges for the duration of the PhD? And the answer is it depends on the college. So if that's something that you would really want, I'd recommend trying to find colleges that do offer that. For example, I'm in a grad college that pretty much only offers housing for first year. But there are some other colleges that I think people can live in college all 4 years if they wanted to.
It's quite difficult to find. I think Exeter has at least 2 years, or like 1 year with maybe optional 2 years kind of stuff. Univ, where I'm at, does 1 year, and then there's a ballot for every year after that, and you get priority if you've had no years of additional living, you get priority on the ballot and this kind of thing. But I would say it's unlikely that you'll be able to live in all years. Not impossible, but it's typically unlikely.
I think there's a few. I know like Christchurch and Balliol, I know of several students there.
Yeah. There's a question about like lab sizes. I think it massively varies. And like joining projects, yeah, you definitely need to like talk to the people on the project to join a project. You can't just kind of like rock up. But generally people, especially if you're in early years of your PhD, are quite happy to work with other people.
This is great. I reappeared from the dark. I think this is really good, and I think you answered a huge number of questions. My sense is we won't ever reach the end of the list because they grow as we speak. But I think you probably covered all of the most important questions. I mean, unless you feel like there's some open questions you really still want to pick up, I suggest we can probably wrap up sometime soon. Or are there specific issues you'd like to still cover? Brilliant. If not, then I'd like to thank all of you. I think this was really useful for all potential applicants, and really showed all the issues that people have in mind, and you answered this really wonderfully. And I think it's particularly important. Some of the things you mentioned, I'd like to just briefly pick up. Work-life balance matters, happiness matters, and this is part of the ethos of the CDT. Pretty much anyone in academia has encountered things like imposter syndrome. That includes very much the leadership of the CDT normally, including myself. We all have this feeling, how on earth did that happen? How do I end up here? Am I living up to expectations? But we strive to have a positive and inclusive environment, and that's what we can do. And we can remind ourselves that, yeah, we're all humans, and we want to do fantastic science, solve a lot of environmental problems, but also want to live quite well. I think all of this matters. I think this is probably a good time to wrap it all up. And we lost some of our panel members already because obviously people are busy with teaching and other bits. So thanks to everyone for attending. Thanks in particular the student helpers for the fantastic responses to the questions. And in terms of if you still now have big questions unanswered, we will add an FAQ webpage section to our webpage at some point. And we hope to pick up the key questions that come out and emerge from today. And we will update our admissions webpages in the next weeks to really reflect everything that is said. We will have supervisor listings, and thanks to all the students for joining. Thanks for your time. It's really, really appreciated. We will have an updated list, a full list of supervisors, at least for the first year, up and running in 1 or 2 weeks. And if you still have remaining questions, please use the contact email that's given on the web pages. It's slightly tricky. I'd love to answer all emails that I receive, but we have quite a lot of interest, so I'm a bit slow. So I think the contact emails is probably the most useful, or reach obviously out to academics that you potentially want to work with, but you're not required to, and you're not required to name them. So thanks a lot for joining, and we're very much looking forward to see all the applications, and we're even more looking forward to working with all of you in the future. Not all of you, unfortunately, but with many of you. All right. Goodbye for now.
Bye. Thanks, everyone.